Alrighty. Happy Wednesday, folks. Hope you're doing all right. All right. We are going to wrap up week 1 of the semester. We did really well on Monday and in lab. That was awesome. So we can actually get started with chapter 1 here in Zybooks after a few administrative updates. So want to put a little bit of information out there for you if you don't know about it. This cool website, Victor's Link, has all the student organizations and clubs that are official. So you can go search for them. There's several out here, particularly for programming. So ACM, or Association for Computing Machinery, is a great organization. ACM is a international organization. So the school has a local chapter, and I don't know how the organization stuff works. So anyone can join ACM. Does all sorts of cool stuff here. So it might be worth checking out, seeing what they have going on, or go to one of their events this fall. Check them out before you join and see what you think. So they're pretty cool. They do some good stuff here. Then another one, which is a little more restrictive here, is UPE. They are a honors society for computing stuff. So they have particular requirements on how you can get in, but they also do some cool stuff around. So generally people like end of sophomore year, starting junior year-ish, hit this 15 CIS credits and 45 credits everywhere else requirement, plus the GPA, because they're an honor society and they get to say we all have a good GPA, so yay. A pro tip, by the way, if you're not good at math, if you take math at a community college and just transfer the credit in, the GPA does not transfer. So a C or better will transfer and there is no hit to your GPA. So just keep that in your back pocket. It's probably a little late now that you're probably already enrolled in math class, but keep that as an option if you struggle with math, or if you're like me and have to take Calc 2 twice to pass it. It's okay. Eventually you'll transfer the credit and not the GPA. So that's all the school knows is that I passed Calc 2, and I will keep it that way. Honestly, though, it was a little harder in my 30s with 6 kids at home to do Calc 2. I just could not keep everything in my head, and the first teacher wouldn't let us have a note sheet with all the formulas on it, and that made it super hard because there's a lot of formulas in calculus. So, but the second time, I had a little more practice. Actually, did some more of the homework. The first teacher was like, "Hey, homework's optional. If you do it, you do it. If you don't do it, you don't do it. There's no points for it." Which, if there's no points for it, I wasn't going to do it because I was busy, had a family and kids and a job, and it's a lesson learned, I suppose. So anyway, UPE, and then you're all here for Python, data science sort of things. But if you like games, there also is a Developers of Dearborn organization. I think we're going to have our friend come out and talk about it briefly, but I just want to put it out here. And it's not just people who do game design. There's all sorts of other stuff that goes into the game industry. So artists, musicians, business people, any other sort of tangent to games here. They're interested in, you can use your skills there, which is fun. So I know a couple of people in their introduction said they're into music. So like some of our musician folks might be interested in participating that way. So, and amazingly, like a good soundtrack really does make a game. It makes it much more of a whole experience, which is fun. I played the cello in high school, or middle school and high school, but I'm a terrible musician. It was fun for me, but I was not good at it. So, but it was fun. If you're good at music, that sort of thing, you probably contribute to it. But all right, so that's out in Victor's link. And then I did add a link here. We have a unofficial, run by students, CIS Discord server you can join. One of the benefits here is they started it before the pandemic. So we have a decent amount of alumni there and current students who unofficially join it. It has no affiliation with the school, right? It's just people who all happen to be in CIS programs have joined together to talk. And it turns out, based on this latest chatter in the fall, that students are better advisors than are advising people, which is really sad, and that hurts. But they can give you tips on what classes are good and stuff that you should focus on and orders for sequences, because I don't know. Apparently, no one could get into advising for like 3 weeks earlier this semester, and like I don't know. I'm not involved with that part of the organization, so unfortunately, I don't have much insight there. Other than everyone was saying, it's much more helpful to talk to an upperclassman to figure out what to do than to talk to advising. So that's an option if you want out there. I've got my Discord server link. I think I mentioned that. You're welcome to join if you like Discord. If you don't like it, just leave it alone. It's okay. No big deal. But we've got class-specific channels if you want to ask questions there. I don't usually have a discussion forum set up in Canvas for you to ask general questions because I just don't like forums. Right? That's like I don't know. It's not. It's fine. I'm sure they're fine. It's an older technology, and like Discord is nice and new, and I can do it on my phone, and you can ping people and that sort of stuff. So that's an option, and that's generally where I'll try and meet people. I can also fire up Zoom if you want to meet virtually as well, or not during my regular office hours if you're not on campus, which is basically before and after class. So you folks are here, then great. But if you want to meet remotely, Discord's easy for that. They have a nice screen sharing tool, or Zoom is fine as well. There's nothing wrong with Zoom. Okay, so we can get into Python. So we actually wrote our first Python program before, or in lab, right, where we printed some statements out. We did hello world. You might have started with hello world and gone from there. And then I have my course repository out here linked as well, I should mention. Yeah, open in a new window, thank you. So all of the code I show in class will show up here in the course repository. Right, so generally I'll try and organize it a little bit nicer here. The main and hello world are just kind of in here, but I'll put everything inside of folders here. So I'm not going to put any of my code in Canvas because Canvas is not for code, right? GitHub is meant for code, so I'll put all my code here. So when I make a new project for some intro stuff, or like this was, what do we call it, like week 1, I'll put it in, excuse me, my 1501 folder. Oops, this one here, and then I'm going to put it inside of another folder. So you folks won't need to do this. You'll have one repository for every project for every lab. Make it nice and easy. I want to just give you one link, so you don't need 15 different links, one for every week. Right, so this is just a little convenience here. So I'll call it week 1. So it'll be a folder inside of that main folder called week 1 here. And then I want that welcome script here. And we can start up a new project. And again, all that other stuff we can just get rid of. We don't need the template here. I just like having main here. Okay. And if I wanted, again, hello world sort of thing, and give it a run, make sure it runs for me. We get hello world, life is good. If I come back to my GitHub client, it's going to see some new stuff and say, hey, there's new files here. That's good. It means I put it in the right spot. So again, if anything in this idea folder changes, like this is the workspace file from the hello world example, just let it change. We don't care. It's not going to hurt anything to change. We see all this stuff inside of week 1 now is there and available and has changed. What I care about mostly is this main file, main py file. There's my Python code. If you can see your Python code here, you can commit it. Just takes that snapshot. It says, hey, this is what that folder looked like at this point in time. I'm going to save it. Once you have a commit, it's really hard to lose it. It is possible. You can run some commands. If you do some Googling and type in the wrong stuff, you can get rid of your commits. Most of the time you won't, so you should be fine. Once we've committed it, right, so this is week 1 started, we'll commit. Now we need to push. So my copy on my computer has this commit. The cloud, the central repository, the origin, does not. So I'm going to push to go and sync with the cloud. Now github.com has it. I can go view on GitHub. And now there's a week 1 folder that I can open up and look at. Inside of there's my main py file. And I can look at the code here. Right? If you can see the code on github.com, I'll be able to see it on github.com. I think everyone who turned in the lab as of last night was great. I was able to get to everyone's code. It was fantastic. Nice to meet all of you. And I think I left some notes. Some of you had some really interesting hobbies or fun facts about you. So that was pretty cool. Turns out you folks do more than just go to school. Who knew? Like, you have lives and do stuff? I don't know how you have time for it, though, but apparently you can figure that out. All right. The other great thing about Git and GitHub, once your code is in github.com out on the cloud, it's really, really hard to lose it because that's how they make their money, selling this service to organizations who do this professionally and want to make money. They'll give it away for people who do open source work and for educational use. If you want to make money doing it, they're going to charge you. Seems kind of fair, I think. So they are really good at keeping the code that you give them or you sync with them, right? So if you are committing your code early and often, is what I like to say, commit early and often, the commits are free. You can, some people I work with make a commit every hour. That's just their habit. They do an hour's worth of work, commit and push, take a coffee break, whatever it happens to be. Sure. Hey, Ernestinus, thanks so much. We've got a friend here on Twitch joining us, cheering 100 bits, donating $1 to the Student Scholarship Fund. Yeah, make college more accessible. That's awesome. Thank you so much, my friend. Every time you commit and push, we've got it out in the cloud. It's secure and saved. Almost every semester, someone comes to me and says, oh, I lost my project because something happened on my laptop. And I say, well, is your code in GitHub? They say, no, I didn't commit yet. Why didn't you commit yet? Well, I was waiting till it was done. You don't have to wait till it's done. You can commit 15 times on the same project, the same assignment if you want. Go for it. I don't do it every hour necessarily, but like anytime I've like gotten to a point where I'm going to go take a break, hey, I'm going to go look at Facebook. I'm still old enough. I use Facebook. I think all the cooler people use Instagram and TikTok and all that other stuff. Um, sure, but if you're going to take a break and go do something else, just commit your code. That's a good natural stopping point. You don't need to interrupt your flow. You're like, hey, I'm in the middle of a project. I'm in the zone. I'm focused. I know what I'm doing. I'm going to keep working. Oh wait, I have to stop and commit. Don't bother with that. Like at a natural stopping point, just go give it a commit and push. It takes like 5 seconds to commit and push. Once the cloud has it, you can't lose it. And again, I don't take stuff late. I say that sucks. You lost your project. You should have committed it to GitHub. I'm sorry. Good luck getting your laptop fixed. You know, that's sort of how it works, right? We can't pause everything because we had an issue. So, if it was honest to goodness terrible disaster sort of thing, I can give you an alternate project, but then you have two projects to work on in the place of one project, and that sort of bad stuff. And I get deadlines. I'm terrible with them too. I will wait until the deadline to do something. I have something due tonight by 11:59 p.m. I haven't started yet, but I will get to it. Assuming I have power and internet at home. The internet was going in and out again as Comcast is going around fixing things. But we'll get to it. So if you don't start to the last minute, that's the risk you run. That bad stuff can happen, and it's really hard to fix bad stuff last minute, right? If you start early, which is we should all be starting early, and I don't do it myself, so I can't really lecture you about it. But we should be starting early, so if we run into issues, they don't really end the world for us. It's not the biggest deal. No one wants to have Coke spilled on their laptop, but it's generally fixable, that sort of thing. I lost a laptop once. My little guy, when he was a toddler, I had my mug of coffee on my desk, and he walked in and he picked it up and dumped it right on my laptop. It's like, oh no. So that wasn't fun. It did dry out though, amazingly. Like it didn't kill it. Like I was able to pour it off right away and let it dry for a couple of days. It works. So that was cool. Anyway, so back to chapter 1. So all about Python. So if the only thing we do is print stuff, it's not very useful. Go figure, right? We want to do more things. So some of the things Python is pretty good at is arithmetic, right? But to do arithmetic, we need to store some information somewhere. So what happens is we tell Python we want to store some value. So to store a value means it's going to save it in memory. So on computers, you have a couple different ways of storing information. You have a hard drive, either solid state drive or the spinning magnetic disks, or even like a flash drive you plug in. That is long-term storage. That's if you save something out to a file, saving out to disk, you've got it around, it's going to stay there, not going anywhere. Memory is not like that though. Memory is fast access and it's temporary. It only exists while the computer has power. So it's loaded in your RAM, random access memory, is really fast to use, and that's where your computer stores stuff. So we can store something temporarily in RAM or in memory for us to interact with and then use. So if I tell Python, hey, I want to have, my favorite number is equal to 42. Now, this is the equals sign, the equals character. It's not equals in Python. This is known as the assignment operator. And stuff happens backwards. So we go from right to left in coding on each line. So what's happening is it's saying, hey, take the number 42 and store it, assign it to this thing I'm going to call my favorite number. Now, later on, anywhere else in my program, I can say my favorite number, and it will give me the value that's been stored there. So if I can go print my favorite number, and there's all sorts of cool shortcuts. I have to remember to show them all to you here. So as you're typing, you use this integrated development environment because it has shortcuts for you. Programmers write these tools for other programmers to make us more efficient. I like to say all good programmers are lazy. We don't want to do more work than we need to. We're efficiently lazy. So I have print, I start some parentheses, it puts in the closing parenthesis for me automatically, and I'm going to start typing my, and notice it lights up my favorite number. This is IntelliSense or Code Complete, or I don't know, whatever you want to call it here. I don't need to type the rest of this word here. I can just hit tab and it finishes typing it for me. I love when the computer types for me. It's like my favorite thing here. So it looks like I'm going to do stuff crazy fast, and it's relatively fast. I've been doing it for like 15 plus years, so I'm generally pretty quick at it, and I drink caffeine nonstop because life is insane. But I'm also using the shortcuts. So if it looks like magic's happening, just holler at me. I'm happy to explain the shortcuts. I try and explain them a couple times, but honestly, sometimes I forget, and I just do them out of habit. So now we can say print my favorite number, and what do you think is going to show up on the screen? 42, that's right. So I hit print, and we get 42. So what's happening is this my favorite number is something known as a variable. So this is a variable. It's known as a variable because the value can vary. I can put any sort of value I want in this variable called my favorite number. And when I ask Python for it, it will go say, oh, I'm holding on to the number 42 for you, right? And then you can go and change the value of it. I can say my favorite number. Now, again, not really equals. We're going to assign a different value to it. How about 7? We'll say, hey, let's take the value 7, assign it to the variable my favorite number. Now when I print my favorite number, what do you think I'm going to get? A 7. Yeah, you guys are awesome at this, right? So variables can hold a single value at a time. The value can be different at different points in our program, but they're only ever going to track one thing at a time. So what happens behind the scenes is your memory stores information. Now, usually memory has what's known as addresses, so the computer knows where it is in memory. Like if I'm going to give you directions to go to my house, I'll tell you what my address is. If you have my address, you can figure out how to get there. If you have a memory address, you can go figure out what's stored in that piece of memory. So our computer, this one particularly here, let's see, has where is it here? About 32 gigs of memory or so. It looks like a little less because reasons. Hardware is funny like that. So 32 gigabytes worth of memory. Gigabyte sounds like a lot, and it actually is a pretty big number here. So you have a single byte. I'm sorry, so a single bit, I should start with, is just a 0 or a 1. It's on or off. That's the basic building block of everything technology, is bits, on and off. What we do is we put a lot of those bits together, generally 8 of them together in something known as a byte. I didn't come up with it, I don't know why, but 8 of them together, 8 bits make a byte. That's generally the smallest storage place that we might have, place we can store something. So if you take a look at your calculator, the Windows calculator is actually really cool. It has a programmer calculator, and it has a mode called binary. Binary mode is our way of saying, hey, I'm going to have zeros and ones. I'm going to have bits. So our regular system is a decimal system. It's base 10. Right? Each place value, there's a ones place and a tens place and a hundreds place, and on and on and on. I wish I had my stylus. I don't have my stylus. I got to bring that next week. Right. So really, what you have is you have 10 to the 0. I think I can do this in Word here. Let's see if we can do it in Word. I want to draw. Right. So this place here is really 10 to the 0 because we're base 10. That's our ones place, and our tens place is 10 to the 1. Tens place. The hundreds place is 10 to the 2, and on and on and on. Right? Because they're just base 10, we happen to be able to multiply by 10 really easily. 10, 100,000, 10,000, on and on and on. We're familiar with that. Binary is base 2 because you're either on or off. So I have 2 to the 0 is this first place, and I have 2 to the 1, and I have 2 to the 2, and 2 to the 3. All right, that's not as pretty as if I had a stylus. On and on and on. And eventually we'll get to 2 to the 7th in a single byte here. So 6, 5, 4, 3, 2, 1. So there's 8 bits in a byte. So the largest value, right? If you don't have to be good at math, that's okay. But we do this a lot, so I can count by twos really easily. So you get 1, 2, 4, 8, 16, 32, 64, 128. So this value here is 128. If there's a bit there, it counts as 128. If there's not a bit there, if you just have a 0 there, it counts as 0. Right? Just like our regular decimal notation, there's this many tens or this many ones or this many hundreds. Same idea here. But with binary, you either have it or you don't. There is no, I have 3 of these places or 4 of these places. You either have it or you don't. So you get 128, you get 64, you get 32, you get 16, you get 8, you get 4, you get 2, and you get 1. So if you add all of these together here and sum them up, the largest value you can have in a single byte is 255. No, I didn't add them together that quickly. It just happens to be 2 to the 8th minus 1. Right? So 128 double is 256, 256 minus 1, 255. You don't need to know any of these numbers off the top of your head, I promise. If you do it often enough, they kind of stick in your head. And I think that's how my Calc 2 teacher thought we would all just know the formulas, because they have been teaching Calc 2 for almost as long as I had been alive in my 30s at that point. So they just knew all the formulas. So you can go between 0 and 255 with a single byte, right? Because you can have them all off or all on or anywhere in between. I can generate any number between 0 and 255 with 8 binary digits, 8 bits, or a single byte. Now, with my binary calculator here, it has this really cool mode called bit mode here. So this is the regular mode, this is the bit mode. I can turn bits on and off if I want here, just by clicking them on and off. So I turn them all on, and it says, hey, that number in decimal is 255. That's a more familiar number here, right? Now, what's cool about binary is that every time I add another bit, just one more piece of information, I literally get to double the range of values I get, because it's the next power of 2, and the next power of 2, the next power of 2. So a lot of times we might use something that is a 2-byte value here, that now I can store a number up to 32,000. Turns out most of the time in programming languages, most of our languages will use a 4-byte integer value. 4 bytes together gives you a range of up to 4,200,000,000 something. Is that a question? Oh, yep, thank you. I did miss that one. Thank you. It didn't really affect my number too much because that was pretty small down there, but thank you. So about 4 billion. Now, the problem is when we deal with integer values or whole numbers, sometimes you want negative numbers. So most of our systems will use a 4-byte signed integer, and signed means you have one bit that is on if it's negative or off if it's positive. So if I use 31 bits instead of 32 bits, I can go from negative 2,147,483,647 to positive 2,147,483. That number. I said it fast once. That was probably as good as it's going to get. Okay, so generally I'll use 4 bytes of information in memory to store an integer. Now, Python is really good and really doesn't care how big of a number you give it. It can store really, really, really big numbers. It's pretty good at it. Other languages are a little bit more particular, and you have to tell it, no, I really want something big. Python says, sure, you gave me something big, I'll store it. I'll figure it out. Now, you might notice with my variable here, there are different conventions, not necessarily rules, on how you name things. It's just the way that everyone does it. And if we all do it the same way, life works out really easily for us when it comes to programming, because we can all kind of read it. This is, I believe, known as snake casing. Pretty sure that's snake casing. I have to Google that again now. Yeah, snake casing with an underscore. There we go. So the reason why we use underscores is if we have spaces here, it confuses Python. Python's a little dumb. So if I try and say my favorite number equals 42, I'm going to get all sorts of red lines here. Now, red lines are the bad lines. Yellow lines are warnings from PyCharm saying, hey, you did something you probably shouldn't have, but it'll be okay. Red lines are, you did something bad, Python will puke on it. So if I have red lines here and I try and run it, it just pukes. And I get a syntax error, invalid syntax. Syntax is that fancy word for the rules of how you write code, or really the rules of language, right? English has a syntax, which is really hard. English is a difficult language. I learned recently there's a particular order in which we use adjectives, and if you don't follow that order, it's really confusing when you try and describe the really big, tall, large purple giraffe. Like you can't mix up purple and large in size. I don't understand it all. But I'm not very good at English, despite having spoken it for 35 years. 34. I guess I didn't start as an infant, but anyway. So just the rules of how it works. So Python doesn't deal well with spaces. So if you get red lines, it's upset with something. You might have had issues when you're using your print commands. If you had without parentheses and maybe you only had one quote here, you're going to get red lines. If you just kind of hover over it, it will tell you. It says missing a closing quote. So anytime we start a quote, we have to end the quote. Great, now I fixed that one. I still have another red line. Now it says end of statement expected. Python's confused. It doesn't know what I'm trying to do here. Well, I'm missing parentheses here, but it didn't tell me that. If I start a parenthesis and miss the ending one, then it knows, oh, hey, I was expecting a comma or a parenthesis. Cool, that I can deal with. Okay, so depending on what the problem is, sometimes it's really a helpful error, sometimes it's gibberish. And it's just going to take some practice getting used to dealing with it to figure out, is it a gibberish error we just need to know, or is it something that's actually a helpful, oh, I forgot something here. So no spaces in our variable names. So the other reason they're called variables is you get to pick the name. So the programmer, whoever's writing the code, gets to pick what they want this name to be here. So I'm calling it my favorite number. Right? My favorite thing to do in code is to name variables. It's a little silly, but there's a running joke in programming land that one of the hardest things in computer science is naming variables. It's really not that hard, I promise. Okay, but what you get is, because Python could care less that I've called this my favorite number, right? It essentially will just substitute in that memory location anytime I use this word my favorite number, and it keeps track and says, hey, you have a variable named this. Here's the memory address. Here's where those bytes are out in memory. Sure, you can say I have x equals 27. Now, anywhere I use x, I can get the value 27, or I can go change the value of x. So you get some programmers who do stuff like x and y and z in their code, and if you go look at their code, you have no idea what x, y, and z are. If I name my variable my favorite number, you probably know what that variable is storing. Right? So this idea that we get to name them here means that we should give the names meaning. Right? The variable name should tell you what it's doing. Now, you don't need to write an essay here. My favorite number was also my football jersey number. Like, you don't need to know all this garbage here, right? I mean, enough to describe it here is fine, and life is good. Okay. Python is also case sensitive. So uppercase letters are not the same as lowercase letters. So if I try and use my favorite number here, it says unresolved reference. It sounds like a gibberish error, but this one is very useful. It means it doesn't know what my favorite number is. We've never told Python what my capital F favorite number is. So unresolved references means I have no idea what this is. So you probably typoed something. Again, you're less likely to typo something if you use the type ahead, right? Some people aren't familiar with it, aren't comfortable with it. That's okay. They prefer typing everything out, and I just smile and nod as they spend a minute typing of every variable name instead of using type ahead. That's fine. You do you. You have fun. But name it something meaningful, and then we'll use that name everywhere else. So the names should be meaningful. You also notice I've got this pound sign here. It's not a hashtag, I promise. It's not the official name. Or really, it's an octothorpe, but everyone looks at you funny if you call it an octothorpe. So the pound sign here is indicating this is a comment. So when there's a comment, when you run your Python program and you say, hey, Python executable, go read the script, as soon as it sees a pound sign, it will literally ignore the rest of the line. So it's a note you can leave in your code that Python ignores. So why would we want comments? Well, we can put a comment in to leave a note, either for ourselves or for another programmer who might come and read our code to do something. Right? Again, I will try and put some comments in to illustrate stuff. Depending on which instructor you have for which class, some of them say you always have to have comments everywhere. And there's whole conventions about comments. You can put places and all sorts of fun stuff here. I come from the school of thought, and it's a little bit rainbows and unicorns style, where like it's a great idea, but we know it doesn't actually work. That you shouldn't need comments in your code because your variable names should be so good that you know exactly what's happening. Right? But some people, especially if you've been programming for decades and decades and decades, will do something like, this is my favorite, or okay, probably a better example. They might have like x equals 42, and as a comment, they'll say x represents my favorite number. If you're going to take the time to type this out and tell me what x means, just use that as the variable name. I don't know why people do this. It drives me nuts, but some people still like doing this. And if they're giving you a grade or they're signing your paycheck, you can smile and nod. Okay, sure, right? Everyone is welcome to their opinion, even if it's wrong. They can still have an opinion. So I don't like this at all. I'm not a fan of this. Okay, so I will try and always use meaningful variable names that tell you what the variable is used for. Okay, so again, this is still not super interesting. We haven't actually done any arithmetic yet. We're just kind of setting the stage here. So we can store stuff out in memory with bits and bytes, right? Put a bunch of bits together, have a place to store it. So everything eventually will get stored in bits and bytes. Now I mentioned I have, 32 gigabytes of memory in this computer. So a single byte is just 1 byte. 1,000 bytes is a kilobyte. 1,000 kilobytes is a megabyte. 1,000 megabytes is a gigabyte. So when you think about how many bytes are in a single gigabyte, we're at 1,000 for kilo times another 1,000, that's a million for mega times another 1,000, that's a billion bytes per gigabyte. Okay, so I have room to store a lot of numbers in memory. Okay, this computer's got a decent amount of memory. Depending on what we're doing, the amount of memory we use will matter. For our purposes, pretty much this entire class, we will care less. We're not going to do anything at the billions scale, right? We're just getting started here. But when you start doing things at the millions and billions scale, memory does become very important, right? If you're trying to store billions and billions of pieces of information here, you might run out of memory to store it, okay? And maybe our laptop, desktop computers just don't have enough room to store it, or maybe we're doing a bad thing and we can do it better. So as you move on, one of the things you'll study eventually is algorithms analysis. Is all about how do I make things efficient in terms of storage and in terms of processing time. This entire semester, I'm just going to say it doesn't matter. If it runs, great. If it uses memory, great. We have plenty of both to do what we're going to do this semester. As we get bigger and bigger and bigger and do more and more and more stuff, that'll become important. So I'm aware that it's important. I just don't care at this point. Okay? So we can store things. So now for some arithmetic. Okay? So if I have variables, I can start doing some arithmetic. So if I have something like, this is my wage per hour, and what should we pick? How much should we make per hour? We're going to make it. It's our program. We can make anything. 20. All right, $20 an hour. Sure. And then hours worked per week. How many hours do we work each week? 25 hours a week. Okay, sure. Fantastic. So then I can calculate. I can ask Python to do the arithmetic for me, and I can say, hey, my weekly wage or weekly pay then is going to, again, sometimes we might say equals. It's not really equals. This is the assignment operator. We're going to take the thing on the right and jam it in the thing on the left. I'll take our weekly pay is equal to my wage per hours. And what do you think we use for the multiplication symbol? An asterisk. Yeah. And X wouldn't work very well because X is a letter, right? So the asterisk here, or the star, times my hours worked per week. Again, I'm not typing this all out here because I'm just typing a letter or two and letting Python suggest it for me, or PyCharm suggest it for me. So it's going to do the thing on the right, calculate this value, assign it to the thing on the left. So now I'll have a weekly pay, and then I can print my weekly pay. And if I only print a number to the screen, it's not all that useful. So what we can do is we can start putting more than one thing in a print. So I can have in quotes here, I can have your weekly pay is, and maybe a dollar sign, because dollar signs are pretty. And you can comma separate things inside of print. You don't have to, but you can. If you want to print more than one thing, you just put a comma between them. So the first thing here is known as a string. It's just a bunch of characters. If you put something inside of quotes, Python says, oh, it's a bunch of text. I'll deal with it as text, or a string of characters. That's why we call them strings, just a string of characters. And then the next thing, it says, oh, here's a variable called weekly pay. When you want it, I'll go get the value that's stored there. Okay, so we're going to make a little bit of money this week, not a whole lot, but we'll make $500. Definitely nothing to shake a stick at. And you notice there is a space in between them. When you comma separate stuff with print, it automatically adds spaces. If you're the kind of person that this upsets, there are other options for you. We will get to them later. Okay. For now, we'll say it's okay and smile. Okay. We can look at some of those options later. Okay.
If you printed without the comma, would you still get the same answer?
I get red lines without that. Now it says a comma or ending parentheses expected. So we've violated the syntax at this point. Yep. So there are ways to do it. We'll get to it later. I want to start a little slow. We'll get to the prettier ways later. The next thing we can do is pay taxes, right? Because anytime you make money, the government wants its share. here, right? So we'll calculate the taxes owed is going to be my weekly pay times what do we pay in taxes? And this is a terrible rough estimate. I know this is not accurate, and we have a different tax system. We'll talk all about that because it makes for a fun project. And I have yet to find a student who actually knows how federal income taxes work, which has been fascinating over the last 10 years of teaching. Which, if you allow me to put on my conspiracy hat for a little while, I think is intentional. Right? It's meant to be a confusing system, but we'll get into that when we get to the project, and then you can hear me rant and ignore me. It's okay. It'll be fun. So if we just do a rough estimate, if we're only making $500 a week, we're probably not paying very much in taxes, but there are state taxes that we have to pay. There are Social Security taxes we have to pay. There are Medicare taxes we have to pay before we even get to federal income tax, right? You're paying 7.5% of Social Security tax. You're paying 2.65% social Medicare tax, and you're paying 4% or 3.9%, whatever happens to be Michigan state income tax. So we're looking at about 12%, even if you pay $0 in federal income tax, right? Is that okay? So I'll say 0.12. So with the decimal place, the technical term for these numbers are floating point numbers because there's a floating point somewhere. There's a decimal place. I don't know why they call it a floating point, but they've been calling it that for longer than I've been alive. So if a number has a decimal place, it's a floating point number. It's not an integer, it's a float for short. We call them floats for short. So we'll calculate the taxes owed, and then we can print that. So you owe, you will owe, and then we'll just comma separate taxes owed. We should probably add our dollar sign too. I like dollar signs. Why not? And then if I just say oh, they don't really know what, right? So how about then I comma separate again, and we'll say in taxes, right? So you can comma separate. There is a limit. I don't remember how big it is. It's probably a little less than a gazillion things in a print. You shouldn't need to print that many things all at once, but eventually you run out. But you can pretty much comma separate until your heart's content. Another thing that might happen too, as you're putting these things together here, a general rule of thumb is that you shouldn't have to scroll left to right on your screen to see your code. If you have to do that, it's annoying. And then if anyone else has to look at your code, it's annoying to them too. And we'd like to not annoy people. That's a good rule of thumb. We want to be a nice, friendly coworker who doesn't annoy people, right? So we shouldn't have to scroll left and right. Now, it'll happen to me a lot because I'm zoomed in like crazy so that it's big enough to see up on screen. So generally, there's about 120 characters or so that will fit on the screen before you have to scroll left and right. As we get better and better monitors and high definition and 4K stuff, you can do more, but PyCharm will start to tell you at about 120 characters or so you've gone too far as a warning, not as an error. Python could care less. You can make this line be 1,000 characters long, sure, but people will hate you, right? Because and really, when it comes down to it, the code, yes, Python needs to be able to read it, but code is meant for people to read it because I need to be able to understand what it's doing, right? Because I've got a memory like a goldfish, right? I'm going to work on something. I'm going to go check my Facebook because I'm not a boomer, a solid millennial, but again, Facebook, sure. And then I'll come back and forget what I was doing. So I need to be able to look at the code and refresh my memory and see, oh, this is what's happening here. This is where I left off, right? So we want the code to be readable, not only by other people, but by you too. Or if you're working on a project, you put it down for the day, you come back the next day, or you do some calculus homework, you come back the next day and your brain's fried from calculus. You need to know where you left off. So code is meant for people to read. It just so happens we write it so the computer can read it too. Okay? So generally we want it to fit on one screen without having to scroll left and right. If you like scrolling left and right, go for it. If you've got a really wide monitor, go for it. I won't ever take points off because I think it's ugly. I promise. Years ago when I was an undergrad, I had an assignment that I turned in. It did everything it was supposed to do perfectly, but I lost points on it, particularly because I didn't have a comment where my instructor wanted me to tell them what my variable represents or some other nonsense. I didn't have a comment. And 17 years ago, I swore to myself, if I ever had a chance to teach, I would not take points off for people not commenting things. And I've stuck to it. I've been teaching for 11 years now. I think this is the 11th year. And I've not required a comment because I think it's stupid. So if your code works, great. If it's ugly, that's okay. That's on you. And it's okay. Some people, and this is kind of fun with GitHub, your code will stay out there on the cloud basically forever. Eventually you can delete it if we wanted to, but after you graduate or start working for a few years and you go back to look at the stuff you did in school, you look at your code and be like, ew, That's really ugly. And that's okay, right? We got the job done. If you accomplish the task, that's fantastic. You get the points. You've done what we were supposed to do here. Doing it nice and pretty is, again, more of the art of computer science and programming, right? It is as much an art as it is a science. So laying it out, making it nice, it really is an art. And with any art, it takes practice, right? So the more we do it, the better we're going to get at it. That's why we write code every week, and then some, right? Some weeks we write code twice with a lab and a project, or however that works out. Lots of code. So we'll see how much we owe in taxes then. So we can run this one. So if you make $500, if you pay 12%, right? Percents are just hundreds places, right? 0.12 is 12%. Okay. You folks are all at least in Calc 1, so I think you all understand percentages. I've had classes where people don't understand percentages, and it blows my mind that our public education system is so struggling. But you folks are good, so great. So 12% of $500 is $60 we have to pay in taxes. So then we can calculate your net pay. So our net pay then is going to be my weekly pay minus the taxes owed, right? The minus sign for minus. Super easy, right? And then essentially let's just print again. So we'll print your take-home pay is, and a dollar sign, comma separate, we'll have net pay. Then we get your take-home pay, 440. Okay? We all right so far? Okay, you just got to shout at me. So you're welcome to raise your hand, but you're also welcome to shout. Happy to slow down or go over something again. So this is like, we're just starting the program. It's okay. It's all new for everybody. If it's not new for you, then great. Sorry you're bored. I apologize. You really don't have to be here if you're bored. Like, you can watch the videos if you're bored. But let's keep going. So we've done multiplication and we've done subtraction. What other arithmetic do we do? We can do addition, we can do division. Sure, how about that? So how about we calculate your tax rate then? So if I know your net pay and your taxes owed, or your weekly pay, we can calculate one or the other, right? And so a lot of times we like to see in the news about billionaires and the percentage that they pay in taxes. It's an interesting value to see, right? Reasons for that we can get into later, but capital gains are taxed differently than income. And if you have billions of dollars, it's not from income, it's from capital gains, guaranteed. But that's a whole other story. So if we want to calculate the percentage of taxes that you pay, I mean, we know it's 12 here, 12%. But if we wanted to calculate it, we could. Right, so we can say your taxes as percentage of income. So the taxes as percentage of income then is going to be equal to my weekly pay divided by the taxes owed. No, that's backwards, right? Arithmetic is hard, right? The taxes owed divided by the weekly pay, right? That should get me back to a nice little decimal, right? Smaller number divided by a big number will be a decimal. Okay, so now print. So you pay about, and then we'll say my taxes as percentage of income, percent in taxes, or of tax, whatever. I'm sure there's a nice English way to say that. You pay about 0.0 or 0.12% in taxes. Now it's nice that it adds the zero for us. There are ways to change how this looks, but if you tell someone they pay 0.12% in taxes, they're probably going to think you're lying, because 0.12% is not the same as 12%. We probably want to fix that, right? So the cheap and easy way for us to fix that is to just multiply by 100. And then we'll get back to an integer value, essentially, that we can then call percentage, rather than the decimal value, which is a percentage that if we have a decimal value, we can't call percentage. It's just the conversion is hard sometimes. So if we give that one a run, now we see, hey, 12% in taxes. And again, I said about, this is an estimate here, it's a rough estimate. It's okay. We don't have to sweat it too much. But now we've done division. Okay. Now, other things that happen though when you get paid, everyone else wants their cut. So you might have healthcare insurance or deductibles, premiums to pay. Hopefully you folks don't have to deal with that, but that's always fun, having to pay your health insurance premiums, which allow you to have health insurance that they then charge you to use, and all sorts of other stuff with deductibles and copays, and our health system is nonsense. But other things come out of your paycheck, right? You might have to pay for parking places, because we do that for reasons. I don't know. Thankfully, we're not doing that here, but we have to have a parking pass, but everyone gets a parking pass for free. So why do we have to have a parking pass? I don't know why. These are the sort of things that keep me awake at night when I drink a lot of caffeine. They used to make faculty and staff pay for parking passes, but they'd give them away to students for free. And that just upset me. Like, why do I have to pay to work here? Like, aren't you paying me to work here? But anyway, so we can calculate that. So we've done division, we've done multiplication. Now, this one, all of you fine folks are really smart and in calculus, so you probably know how order of operations works, right? But you get these sort of nonsense things where there's like some mystery value will be, and then someone will say, happens on Facebook because boomers love these things. Like, hey, no one can solve this. What is 9 divided by 3? And then they'll just in parentheses put 3 or something like that. But we know math people are lazy. Sorry if you're a math major. But really, with a parenthesis here, that just means there's a multiplication sign, right? That's all that means. We just are too lazy to write the multiplication sign. So when you have something divided and multiplying, order of operations applies, right? Please excuse my dear Aunt Sally or PEMDAS or whatever they say nowadays, right? Parentheses first, and then exponents, and then multiplication and division, and then addition and subtraction. And I've had people argue with me that because you say multiplication first, you have to do multiplication before division. And I just look at them like, how did you get past third grade? I don't understand it. What happened in your third grade teacher? Did they just give up on you? Like, multiplication and division have the same level of precedence. We just can't say 2 words at the same time. So one has to come first, right? So you don't do 3 times 3 first because it's multiplication. Even if they're touching in math land, you don't do it first just because they're touching. There's no additional order of precedence happening because they touch. We're just too lazy to write the multiplication sign, right? Take this to any math teacher here on campus, they'll tell you the answer is 9, right? If they tell you otherwise, don't take their class, okay? That might be fun to survey some people, but I'm pretty sure all of our math faculty will pass this easily, and they'll just look at you like you're wasting their time, even if it's amusing. But right, multiplication and division have the same order of precedence. You go left to right. Same with addition and subtraction. Same level of precedence. You go left to right. Okay, so order of operations still applies. Operations still applies in Python. Operation. Look at this. PyCharm will spell check me, and that is like my favorite thing that it does because I'm terrible at spelling here. Okay, so right, I think most people would say like 9 divided by 3 times 3, right, is really 9 divided by 3 times 3. Okay, just to if that helpful to leave a note so that this makes a little more sense why we're off on this tangent here. We'll have this code. Okay, so that some mystery value we know is 9, is not 1. And you don't need to argue with boomers who say it's 1, because the way they did math is the right way to do math, and the only way to learn math is the way boomers learned math. And I don't get why they like to argue on the internet so much. I don't understand it. It hurts my head. But like, that's their favorite pastime. Like, it's not sports anymore. It's not baseball anymore. It's arguing with people on Facebook. Just get a life. Do something like useful with your time. But all right, so we can do arithmetic, follows order of operations. We can have these variables. Now, this is not really the most interesting program though, because every time I run it, it will literally say 500, 60, 440, 12%. It would be more interesting and actually more useful if I could put numbers in when the program ran, right? That would be much more fun. So we can deal with what's known as user input. I'll ask the user being whoever's running the program, to enter a value. Because now it's interesting. If TurboTax always told people, hey, this is how much you pay in taxes, they'd get sued real fast, right? Because it has to be based on what the user inputs, based on how much you made and all your deductions and all of our tax law nonsense. That's a whole other story, right? So, oh, really? There's 2 L's. So what we want then, instead of it always being 20 and 25, is we want to ask the user. So it turns out there's a way to get input from the user to ask them to enter a value. It's known as input. Python's pretty friendly like that. So instead of being 20 here, I'm going to just comment this one out here, and I'll say my wage per hour is equal to an input, and then in parentheses, what do we want to ask the user? We'll say, please enter your hourly wage. Now, there's a problem here, though, and I'm going to run it here, and you'll see in a second. So it says, okay, please enter your hourly wage. How much do you want to make per hour right now? 26. Enter. Oh, we can't multiply sequence by non-int of type float. When we got to taxes owed equals or being assigned the value of weekly pay times 0.12, Python says, I puke on you. I give up. I can't take a non-integer type or a sequence and multiply it by a float. Because when you enter values, the only thing Python knows is that it is a string of characters. It's just a bunch of text. Now, it can do a string of text times 25. Python is smart enough, silly enough, foolish enough to say, oh, you have a string and you want to do it 25 times? Here's 26 times 25, but it's the string value 26. It gets repeated 25 times. Sure, it's not what we want though, and Python, you've done a bad thing, right? So what we want then is we want to convert this to a different value. And now most people probably don't make an even integer amount per hour. Maybe most is wrong, but a lot of people might not, right? Maybe it's like 19.25, and then when you get a 25-cent raise, they're like, hey, you got a raise. And you say, well, that's a lot less than inflation was. You're screwing me. I actually got a pay cut this year. And they say, well, you got a raise. Good job. Like, I don't understand. But so we don't want this as an integer because I don't know if it'll always be an integer. I want it as a floating point number. So I'll say float, and then in parentheses, convert something to float. So whatever I get from input then, again, we're still following order of operations here. The parentheses happen first. So the input of please enter your hourly wage happens first, and that's handed to the float conversion here, and Python says, oh, I'll take this, turn it into a float. So let's give that a run. So enter your hourly wage. If you type in 10.25, it's going to crash. They'll say cannot convert string to float 10.25. Right? Python's not magic. It has no idea what 10.25 means. So it can't convert it to a float. But if you give it something like 10.25, it'll convert it for you because it knows how to do that. It'll try. Bless you. It'll try and convert. Okay. So you wanted to make 26. So at $26 an hour times 25 hours a week, you make $650. You pay $78 in taxes. It's about 12%. Again, that's a little silly here because we know what that value was. Okay. But now we can also do that with hours worked. So I'm going to just copy paste here because I'm lazy. We'll say please enter how many hours you worked this week. Again, I'm going a little bit off the screen here. I apologize, but if it's not zoomed in, it's not so bad. So will it be okay? The problem is Python gets funny if you try and move stuff on other lines. It really likes stuff to be on a single line. There are ways to do it otherwise, but it can kind of get confused if you're not careful. So like this is on a separate line and you have to add a backslash to tell Python, I really want it to be on the next line because otherwise Python gets confused. Python is very sensitive to new lines and spaces. So I generally try not to do that just because it confuses Python. And then I get confused whether or not I need a backslash. Like to do this, I don't need the backslash, but to do this one, I do need the backslash. And I can never remember why. So I just let PyCharm do it for me usually. So we'll just leave it there. So we can enter the hours worked. Okay, so we run that one. So what's our hourly wage? How about this time? Should we get another raise? How about 28 bucks an hour? All right, and how many hours do we work this week? 3 hours, okay. Not a lot of work, but that's okay. You're busy. You're busy people. So $84, $10.08 in taxes. That's our take-home pay. 12% in tax. Again, sure, we know that one. Okay. We all right so far? So we're getting some input from the user and converting it. Now, the other reason these are called variables, because the value will vary. I have no idea what this value is when I hit the start button. I hit run. Python doesn't know what the value is either. The value depends on what it's given. So the value can vary every time it runs, which actually makes it a much more interesting program. It's a much more useful program because it can change every time it runs now. Okay. Right, and we can do arithmetic, we can save the value. So every time we tell Python I want to assign a value to a variable, if it's a new variable, it goes out and says, hey, operating system, I need a place to store this value. And it will go get so many bytes of memory and remember where those bytes of memory are. It's fantastic. So for our purposes, we're not going to use a whole lot of memory. Later on, I'll show you how you can use a lot of memory on purpose, and like you can actually see it like impact the computer. Like right now, I've got 9.5 gigabytes used. We can like really crank that up and start eating a lot of gigabytes of memory just for fun as an illustration, but we'll get to that later. So for now, like we used a couple bytes and a couple bytes and a couple bytes and a couple bytes. Sure. So when we do arithmetic, Python is asking your processor or your CPU to do the arithmetic. So Python actually asks the operating system to do it. The operating system asks your CPU to do it, and then it gives the result back to Python. It just happens really, really, really fast because computers are electronic, and electronics are really fast. And you might think Windows is really cool, and I'm doing a bunch of different things at once, right? I'm running OBS, I'm running GitHub, I'm running Word, I'm running PyCharm, all at the same time, but they don't all happen at the same time. Right? Unless you have more than one CPU or more than one processor, a processor could do one thing at a time. What it happens to do behind the scenes is it does a little bit of all the different tasks and then moves on, and does a little bit and moves on, does a little bit and moves on, and does a little bit and moves on. So if I look back at Task Manager again, these are all the things that are running here. My computer's doing a whole bunch of crap, right? And most of it's Windows is doing a bunch of stuff here. Windows' job as an operating system is to ask the CPU, the processor, to please do something for this program. It'll do the thing, and then Windows will say, hey, please do this thing for this program, and this program, and this program. So it looks like it's doing multiple things at once. It's just doing one thing at a time really, really, really fast. Okay, so I can run multiple programs. They're all open, but the processor only does one thing at a time. So OBS is like always doing stuff. Anytime it can get the processor, it's going to do something because it has to grab the video, convert it, and push it out on the network and do all sorts of fun stuff. Okay, but we'll do all that. So we can ask the processor to do stuff, and then we can go store the value in memory. Later in the semester, we'll get to storing stuff on disk or writing files that will stay there. As soon as Python is done, the operating system will free up all of this memory. So every place I had stored values gets returned to the operating system. So the next time a program wants some memory, it says, hey, this spot's open. It's an open parking spot. There's nothing parked here anymore. You can have it, essentially. And we'll go free it up. Okay, so let's see, how are we doing here on Zybooks? I thought I was signed in already. Okay, I was signed in. So if you got a chance, hopefully you picked up Zybooks already. It's cheaper than a regular textbook. Still, they're a little pricier now that they've been bought out by an actual publisher, but they're fantastic. You can go through and do the exercises here. So like you'll see these Xi labs that you'll work on. It will check to make sure that the output matches what it expects, and it can vary the input on you. So you could have a program like this that uses inputs, and the Xi lab will feed it different inputs to make sure that you're actually doing arithmetic and not just saying, hey, spit out, you made $500 this week, you paid $60 in taxes, right? Because that will work one time, but then if you change your input, it won't work every time. So it runs multiple times and goes through. So the Xi labs I like, they're a little tedious, and they are very particular about spacing, which is a good chance for you to pay attention to detail and say, okay, I had 2 spaces here instead of 1 space here. You'll probably hate it, but it's a good chance to like dig that deep into your code and be that specific with a fine-tooth comb and make sure you don't have extra spaces places. So we can run those to do your programs. Okay. So we got input and output, Python, errors, development environments, programs, yep, language. The language history is interesting and all. Oh, look, the salary calculation. I stole it from, everyone can calculate salary in any language you write. They don't have the rights just to that, but okay. So that's about it for chapter 1. It's fantastic. I'm not going to actually have a quiz on chapter 1 for you. We'll get into Zybook quizzes starting with chapter 2, but I will post a syllabus quiz, which is essentially free points for you to make sure you've read the syllabus and that you agree to our academic integrity policy. Because when I have to report someone to the dean this semester, which happens every semester, despite me like going on a long rant about it and you guys just shaking your head like, why would someone cheat? How stupid can they be? They're going to get kicked out of school. Yeah, they are stupid. Right? They're going to get kicked out, and hopefully we catch them. That's the goal. That you have agreed to the policy. So when I turn in all my paperwork to the dean, when I have to give them this entire file full of stuff, the stuff you did and what I told you and all that nonsense, I include the syllabus quiz that says, look, they agreed to the policy. They knew what the policy was when we started the class. Okay, so that's another reason I have it. And then it's free points for you in the quizzes category. So I'll post that later. It'll be due next Wednesday, 11:59 p.m. So I'll generally have quizzes on Wednesdays as long as our schedule holds. I think we're pretty good for that. We'll do a chapter quiz pretty much every week. Sometimes we have 2 chapters, or like 2 weeks. Oh no, 2 chapters. So I'll just do a single quiz for chapters 2 and 3. We won't have like 2 different chapter quizzes. Don't worry about it. I think we'll be able to move up a little bit. So maybe we can start on chapter 2 next week, and then we won't finish. We might finish 2. We won't get into 3. Maybe we'll have a whole week for chapter 3. That'll be really good and pretty nice there. So this might adjust a little bit, but next week we'll have our first Zybooks quiz. We have our first syllabus quiz this week. Pick it anytime. There's Labor Day next week, so no lab, no class for Labor Day. Go out and do something fun, or go to a parade or an actual labor event sort of thing. The reason why we have Labor Day. Go thank a labor union, and we'll go from there. All right, questions, thoughts, concerns? Yeah.
Is there a due date for like the dive chapters each week?
No, because it's a lot of work for me. So as long as you get it done by the end of the semester, I think I even put it out to like that Friday, 12/9, then I don't care. Because I'm not going to go run the report every week and enter scores. I'll just be honest. If you keep ahead, great. Or if you keep up, great. If you get behind, people have done the entire Zybook in a week. And why? I mean, that's a big waste of their time, and then they didn't actually do. I don't know, but sure, I'll give them the points anyway because they did all the clicks. But it makes for a terrible finals week to have to spend hours going through your Zybooks clicking. And honestly, the Zylabs take a decent amount of time. So, the other thing, so you'll find in the syllabus quiz a question. The general assumption is that a college class requires 2 hours of work outside of the class for every hour spent in the class. So this being a 4-credit class, the general assumption is it takes about 8 hours a week worth of work outside the class to do the readings, take your notes, do your studying, work on projects and assignments and things. I generally don't count the labs because the goal is you walk out the door when lab is done with the lab done. If you take it home for homework, that's on you. You're welcome to do it. You've got all week to turn it in if you want it as homework instead of finishing it before you walk out the door. But that's up to you. So we do 2 hour and 15-minute lectures, which counts as 3 hours worth of lecture time, and an hour 45 in the lab, which counts as 2 hours worth of lab because academia is a racket or something. So it's almost like a 5-credit class, essentially. But we count it as 4 credits, so you're getting a little bit of benefit there paying for 4 credits. But about 8 hours worth of work outside, especially once we start getting into the projects. There will basically always be something for you to code. If you finish it early, great. If you don't finish early, or you don't spend that week starting it because it's not due till 2 weeks from now, you'll probably have like 16 hours worth of work. And not exactly. They generally don't take all that long. And I can solve all of them in class. So they're not super large projects, but as you're learning and it's all new to you, it's going to take you longer. You have to deal with syntax errors. You have to get the red lines and figure out why you're getting red lines. You have to send me messages, which is great. Happy to help you with those messages. So if you send me the errors, happy to help you work you through them. Eventually, you'll get used to them and you'll be able to fix them yourself. It's not too big of a deal. That's why we have lab every week, so I can walk around and see the computers and do that every week. We'll do the projects, and then the final project is large. We'll have all month to work on that, and then we'll present them to the class. It should be a lot of fun. And then we'll call that a fall semester intro to programming in Python. Okay. All right, you folks have a good Labor Day. I will see you next Wednesday